up first one, top left, George has a candle in the shape of a cylinder. We see a radius of 4, a height of 6. It says the candle melts at a constant rate. The table below shows the amount of the candle in cubic centimeters melted off at the given number of hours after burning started. Find the percent of the candle that is melted off after 7 hours. So on our table here, we've got 2, 4, and 6. So let's figure out the rate per hour. How do we figure out the rate per hour? 60 divided by 2, because both of these have a change of 60, and both of them are a change of 2 hours. So it doesn't matter which one you use here. Okay, 60 cubic centimeters per 2 hours. So that gives us, what, 30 cubic centimeters for 1 hour? 30 cubic centimeters per hour. So after 7 hours, how much of the candle would be melted off? 210, right? Because after 6, 180 was melted off. So add that 30 for 1 hour. Okay, so we've got 210 that's melted off. But that's not what the question's asking. It says find the percent of the candle that is melted off. Find the percent of the candle that is melted off. So that must mean I need to know how big the candle was to start with, right? I need to come up here and find my volume, pi r squared h. So pi r is 4 squared, h is 6. It says use 3.14 for pi and round your final answer to the nearest percent. So let's use 3.14 for pi. So our original volume is 301.44. Find the percent of the candle that is melted off. So after 7 hours, 210 cubic centimeters is melted off out of our total original amount. And we want that as percent, so we multiply by 100. It says round to the nearest percent. So the nearest percent here would be 70%. So 210 over the 301.44 times 100 is where we got that 70% from. Do I need to go? I feel like I went over that really fast. Do I need to go over any of those steps again? I feel okay about it? Okay. All right, let's look at another similar one. Okay, we have a cone over here that they're saying is a cup. It was filled at a constant rate. It started empty. After 2 seconds, it held 70 cubic centimeters of water. Find the percent of the cup that is filled with water after 3 seconds. So similar thing. We got to figure out our rate per 1 second. So what's our rate per 1 second? 35, because we did 70 in 2, so that's 35 in 1. So after 2 seconds, it had 70 cubic centimeters. It's asking us about 3 seconds, so how much do we have after 3 seconds? 105, right? We had 70. We're doing 35 per second, so 70 plus 35 is 105. Find the percent of the cup that is filled. So we've got that many, or that much volume. We got to figure out how much volume is in the whole cup, right? So volume of a cone, 1/3 pi r squared h. Radius is 4, height is 7. It says to use 3.14 again, so let's do that. 1/3 times 3.14 times 4 squared times 7. So our volume of the whole cup, 117.227. We have 105 out of the total. I'm going to keep that number in my calculator there. Multiply it by 100 because it wants the percent. Nearest percent would be 90%. So it's almost full, which we could see that. The whole thing holds 117. We've got 105, so it makes sense that it's about 90%. It's almost full, but not quite there. All right, let's look at one more like this, and then I'm going to let y'all practice. Andy had a snowball, which they say in this case is a perfect sphere, with a radius of 3 centimeters. He wanted the snowball to be bigger, so he spent 4 seconds packing more snow onto it. Each second he spent packing, the snowball's radius increased by 0.25 centimeters. What is the ratio of the current volume of the snowball to the original volume of the snowball? So let's find the original volume. Volume of a sphere is 4/3 pi r cubed. The original radius was 3. So 4/3. I'm going to leave the pi out right now. 4/3 pi r cubed. Just leave out the pi. So the original volume is 36 pi. Okay. Currently, volume 4/3 pi. What is the current radius? Be careful, that's what they want you to think. 4, because he spent 4 seconds packing, and each second the radius increased by 0.25 centimeters. So 0.25 centimeters 4 times adds an additional centimeter. So now the radius is 4. So 4/3 times 4 cubed. Ugh, not a pretty number. Let's turn that to a fraction. 256 over 3 pi. It says, what is the ratio of the current volume to the original volume? So we do current 250, let me do this in a different color. 256 over 3 pi over the original. The pi's cancel. Okay, the pi's cancel. So it's just 256 over 3 over 36. Turn that into a fraction. 64 over 27. 64 over 27 is the ratio of the current to the original.